Hi everyone, welcome to the session on Ballerina, cloud programming language for replacing cloud native middleware. I hope you are all connected and participating. The system work in a way that if you have any questions, you can submit through Slido, and me and my assistant will be monitoring that to answer any questions while we are proceeding. Do ask questions if you are stuck with anything, if you need any help, if you need any clarifications. You can of course send us a message. First of all, so I have created a GitHub repo with the plan that I'm going to follow. So I recommend everyone checking out, basically cloning this repo and get the content, because it will have all the sample source code and the details you will need to progress, and it will be easier to follow in that way. So I will share the link with everyone. So please go to this repo, basically do a git clone and get the content. So I hope I hope you have gone through the earlier prerequisites, and so that we have to download and install some applications. So these instructions are again repeated here. So if you start from the beginning, from the prerequisites, you will be able to get those links and install them. So first you have to start with the Ballerina distribution. This is the link is there. Just navigate to the ballerina.io website and click download Ballerina. The latest version is 1.2.0, so please download that. So there are installers for each platform, so Windows, Linux, and for Mac OS. Do download the respective package and do the installation. And afterwards, if the installation has succeeded, you will be able to execute the Ballerina command. So just do a Ballerina version and see whether you get an output. And also the next step is to installing VS Code, Visual Studio Code. So we will be using Visual Studio Code to do the actual programming. in VS Code there's a Ballerina plugin that you can install. So simply go to VS Code, and under extensions, if you search for Ballerina, you will be able to find the Ballerina plugin. So simply install that from there itself. So you can directly install it within the within VS Code. So after you successfully install, and then we have some other additional dependencies. So we also have some scenarios that that requires Docker and Kubernetes as well. So mainly, if you have a local Kubernetes setup, that will be fine. Or else if you have a remote Kubernetes cluster configured, or else just follow these instructions for each platform, either Docker Desktop or Minikube, and install it locally. And also there's a scenario with AWS Lambda as well. So if you are going to follow that aspect as well, you can install the AWS CLI, which is available for each platform. So if you have any questions regarding these prerequisites or any concern on the installation, please drop us a question so we can check on it. So again, the structure of the workshop is, so I'll be explaining the different concepts in the Ballerina programming language, how it is used in certain scenarios, especially in the cloud native middleware use cases and for creating microservices architectures. And while I am introducing the concepts and the specifics of the language, I'll be doing hands-on exercises as well. So I'll be doing some basically some live coding to explain the features and how certain scenarios can be implemented. So you can follow me in the coding, or else also you can simply use the samples, the fully working samples that's already there in the repo, and you can directly run them. So either way, try to follow the flow. And if you get any doubts or questions, you can ask me. Okay. So I also have Lakmal assisting me also. So in the same time, so he'll be helping me with the questions as well, so I can parallel do the sessions, and we can keep on asking any questions that are sent to us. So let me start by explaining what Ballerina is, how the project started, why it's there, and so on. So Ballerina is a basically a full general purpose programming language. So initially it was started to replace like traditional middleware products like config driven ESBs and so on. So we wanted to do something better. So we wanted to have the flexibility of a general purpose programming language while also having these high level abstractions to make the development easy. So we started creating so as I mentioned, creating a solution for this. But basically we ended up with a fully fledged programming language, and basically we ended up having like best of both worlds, like having these middleware like concepts in a programming language, but also having the flexibility when you need to drill down and do these specific things more easily. So I'll explain what these are, basically how these are tackled in a programming language. So if you look at the general structure of the workshop, I have several parts, basically 4 parts mainly divided into. So in the first part, I'll be introducing the Ballerina language, the basics of the language itself, starting from type system, its flow control functions, and basically the main things you would get in other programming languages also, and some other unique features that's specific to Ballerina. And part 2, I'll be talking about the network awareness of the programming language. So this is where Ballerina becomes special compared to other languages, where we have these high-level abstractions to represent aspects in the network, like communication endpoints, resiliency transactions, and so on. Those are like built into the language itself. So I'll be talking about those concepts, the programming model, the supported protocols, and so on. And also then we move on to the inbuilt the observability capability we have in the language, like how we have made it easier using the language itself to have good defaults in making sure we track all the events as much as possible without much of the developer intervention. So we will be looking at that as well, and also finally we will look at the deployment aspects, like how we, after we create a scenario, after we create an application, what are the ways to deploy them especially in the cloud native era. So we have like Docker, Kubernetes, serverless frameworks, and so on, and how to do CI/CD with them, and so on. So I'll be basically looking at those as well, and showing some examples on how those are done. So I hope everyone got the prerequisites done. So if you have any questions, again, I can we can answer. I hope you got the link I shared earlier for the GitHub repo. Let me send that again. Let me double check that the link is sent. Let me check on the ways to share the links. Let me check on this a bit. Please hold on for a bit until we figure out how to send messages through the system. Okay. So let me send the link again. For some reason it says waiting for review. Can others see the link? I saw one of you said you can't see the link. Can you see it now? I guess you can now. Can't see the GitHub link. What can you see? Let me try that again. Okay, how is the situation now? Okay. Oh, great. So I think the link can be seen by everyone now. Sorry about that. There was some delay there. Okay. Hope everyone can see the link now. Please navigate to that and do a clone of the repo, the full repo, and please let us know if you need some more time to go through it and to download the distributions and so on, so we can give a bit of time for you guys. Please let us know. Okay, so yeah, again, if you get anything, just send us a question. So I'll start with the program. First thing again I'm going to do is start with the introduction to the Ballerina language. So I will show you some of the features and how the basics work. So let me go to VS Code. So again, yeah, we will be starting with the basics, but we will gradually go to the more interesting concepts like the services, the observability, and so on, the container support, Kubernetes, and so on, when we come to the other sections. So the first, this current section would be purely based on the language features and the basics. So let's start with a simple, basically an hello world program, what you would get in any language basically. So in Ballerina also, so Ballerina is the syntax is very familiar if you are used to programming in languages such as Java, C++, JavaScript, and so on. So the concepts and the syntax is it would be very familiar to you. We start with the main function, so that's the entry point. So that's one of the entry points to a Ballerina program. So I'll explain what the other one is soon. So in Ballerina, so we have Ballerina modules. So in the same way as we have like packages and other libraries in other languages. So this is a module that we import, and we import IO module and we just do a print. Let's see how we run this. So in Ballerina, so there are two ways of running a program. So either we can run it directly by saying Ballerina run hello.val. So at this point it will automatically compile and run it in the same time. You can also do the compilation first by saying Ballerina build, and it will basically this way it will compile and create the executable, and we can run that run the executable directly after that. So when you say then Ballerina it runs. So the build and execute option is the recommended way when you're actually deploying something, obviously, because then you don't have to do the compilation over and again when you run the program. but for simple testing and so on, we can just use Ballerina run and directly compile and run at the same time. So you may have noticed that we created a jar file. This indeed generates Java bytecode. So this Ballerina, the runtime runs on top of the JVM. Ballerina is actually not tied to a single platform, but the current runtime, one of the runtime is based on the JVM. But in the future, we have some plans on creating a native runtime as well. But the current implementation is based on the JVM. Which is why it creates a jar, and it will basically use the JVM to run its programs. That's the first thing. So I hope everyone managed to get that done. Okay, I just got the old messages in the chat room. Okay. So yeah, if you guys need any help, just again, please let us know. So let me continue with the basically the basics of the language again. We'll start with the type system. So Ballerina has first of all is some of the basic types that you would be familiar with, like the int, float, booleans, and so on. String type. Basically, so there's only int and float. There's no long. So in the built-in types, we don't have here directly long and double. So these are 64-bit integer and a 64-bit double precision floating point number is actually float, and so on. So these are all familiar things for basically a statically typed language. So again, something to specifically note: Ballerina is a statically typed language, so it's not dynamically typed. So everything is type safe. So when you compile, it makes sure that in the runtime we don't have any type related errors and so on. So it is type safe. Another thing type system wise, something that is unique in Ballerina is it has a structural type system compared to a nominal type system in the language like Java, C++, and so on. So I'll be going through that when I introduce mapping types and so on. To see what this difference is. So again, so we have the similar array support and so on in the language. So arrays can be fixed or dynamically sized. So here when you say this becomes dynamically sized, and if you do something like this, it automatically gets extended or resized. So if you give fixed values such as you can also give fixed values and make it fixed also, or else it will be dynamically sized. So the array in Ballerina can be used to implement queue and stack operations. So it has operations like push, pop, and also shift operations. So which can you do to create a first in first out structure. So using these combinations, you can basically implement these stack and queue data structures. And so after arrays, Ballerina has a tuple concept. So tuple is basically a fixed size. It can be seen as a fixed size array, but it can have multiple types for each position. For example, I can say something like this. So it says this tuple type consists of a string and an int at these two positions, the first and the second, and that's it. So you can't change the size of it. So you can only address the values using positioning values. For example, t10 is the first string value and 1 is the int value, and so on. So it's basically a fixed sized structure with where each slot can have its own data type. So in Ballerina, how the type system works is, so this section here is called the type descriptor, where this is the part where you actually define the type, how you explain the type. So we call this part the type descriptor, and from that type we create an instance. So this will be made clear when we use other types as well, like other mapping types, like records, errors, and so on, because we can actually say type so this becomes type, the name, and the type descriptor. So then we can actually use t1 as the type and create instances of it. So so this is doable because of this format that we use. Whenever we have a type descriptor, we can create a new type out of it, like this. Also, when we get to tuples, so there is an operation called the tuple destructure. So you can say, you can directly say so then when you have this syntax, you give the two variables and you have a tuple value in the right hand side as an assignment. So then it destructures the its content and assign the values to these different variables. So it becomes a convenient way of assigning the values using a single statement. And so that's it for tuples. Then we have in Ballerina we have JSON and XML types as built-in types of the language. So we can just create a JSON like this. And so on. So this becomes a JSON type, a JSON value. So the JSON type is a bit of a special type. We call it, it's defined as a union type of multiple inbuilt types you already have. I'll be explaining what an union is in the coming sections. But anyway, the JSON values can be used in the syntax as we use in JavaScript and so on. So so let's do a quick print and see how it looks like. Oops. Okay, so you can see you can then access like that. And if you want to add some values into an existing JSON value, we have an operation called merge JSON. So let's say I'm going to add another attribute called ID. You can call this merge JSON. And this operation can actually fail also. So so because of that, so this actually returns a union type. I'll explain how this is resolved later, but for now we'll be basically assigning the union typed value to this variable. So what is this var usage actually? So which I just used. So it's a way to infer the data type from the context we have. For example, if you say var x equals 10, x actually becomes an int. So it's not where the type. So after this, you can't change the type of this like we see in other dynamically typed languages. So this actually in the compiler, this becomes an int. So it's the same as we typing int here. So it's type inference that happens here. So that function is there as well. Let me increase the font size here a bit. I hope this is better. Okay. So that's it for type inference. So here also, when I said var, this is actually a union type. It actually becomes this. So rather than me writing that whole thing, I can just say var and it will int type. Alongside JSON, we also have XML data type support also. So if you have any XML values, you can just say XML and so on. So you can see the code automatically validates the XML literal. So this is not just a text value that we are setting, it's an actual XML value. So it validates the literal values we give and basically give a compiler error if we don't have well-formed XML here. And also XML namespaces can be defined as well. So if you just say like that using this syntax, and okay, sorry about that, guys. So we had some technical difficulties. I guess we are now back live. Please send us a chat if you also get any issues like that, if you notice something. Okay, let me continue. So I was going through the XML support in Ballerina and JSON. So these are two of the most used data formats that we use. Now mostly JSON actually, but we still have rich support for both options, as I was explaining earlier, from the program, from the namespaces, element access, iterations, and so on. All are possible within the language syntax itself, so you don't have to get external other libraries into the picture, but rather they are built into the language. So those are some of the basic types we have in Ballerina. So let's move on to the other sections. After that, so we'll do a quick check on other and we'll move on to the mapping types. If you are following the code, there's a mapping types .bal which contains all the sample code which you can check. So here we'll first start with the basic map structures we have in the language. So maps are basically string keyed key value pairs. So the value can be any type you give. but the key is always a string. So it's a parametric type. So here you can just give so it's similar to the JSON object format we saw earlier. So it's basically the same syntax. So you can say like this for define the mappings. And you can use this format in looking up and assigning values as well. So then we will move into the other mapping type called records. So records is basically mapping type, but in its elements, each element can have its own type. So the key is still the string, because we give a name like that. So these are basically string values, so string identifiers, and these types obviously can be different. So these compared to the map where we restrict to a specific type, this can have multiple types. So let's create like a person structure there. So let's call it name and age. And also when you're creating, you may have noticed that we have these in place. We use them to close the record. So when you close the record, you can't, in the runtime, you can't add any more fields to that value. So in the case you do not do that. So if you have it like this, so we call this an open record, and after you create an instance of it, you can actually add other fields to that as well. Like you can do this and say like this. So if you close this, you can't do that, then it becomes a compiler. So that's a feature we have. So these are especially useful when we have like network data mining use cases and so on, where the actual incoming attributes and so on can have additional fields where we do not know from the base type. And so on. So in those times, it's useful to store those additional types as well. We can also limit the fields that can be added as so. In a closed record, we can say we can close it, and we can say additionally only it can have ints. So when you say that, so this ID must be an int. Likewise, so you can't have anything else. So you can control it like that as well. So let's create another structure called student. So student will also have pretty much similar fields, but we'll have an additional field called college. Which college the student goes to. Now I'll talk a bit about the structural type system I mentioned earlier that we have in Ballerina. So when it comes to type equivalency, which variables can be assigned to where and so on, this behavior comes into play. So for example, if I create an instance of person p1, so can I actually so we can't do that because it's expecting a student and we are giving a person, so it doesn't work. So what about the other way around? So if we make this a student, will this work? So this actually works. So why were we able to assign a student to a person instance, a person variable? Because according to the subtyping rules, a student is actually a person. A student basically is compatible with type. So if we just look at this from a high level, so the student actually has all the properties that's required to be a person. So it has a name, it has an age, it has an extra fields, but that doesn't matter since it has the required fields and attributes needed to be a person. You can actually assign S1 to a person. So this is the structural type system aspect. So it doesn't look at the name of the types, but rather it looks at the values itself, the value, and see whether it is compatible. So that's the main difference when you look at other language like Java and so on, which is a nominal type system based language, but we here used structural type system, which is very convenient when you go into use cases like network communication, other dynamic behaviors like when you want to generate data items in stream processing or anything like that. The structural type system becomes very useful. So so that's it for how you basically create the record types. So also in the records we can actually mark certain things as optional as well. So if you can just say college and you can put a question mark here, and this becomes an optional value. So you can't access that field anymore like this because it's an unrequired field. You have to access it like this, and even then you have to say it's a string or it can be a nil value. So let me explain what that is. So one of the main things in Ballerina is it has union types. So you can create a new type called like int or string and create an instance of that saying likewise. So this is a union type. So this is the type descriptor. So it is the one that describes the type, what I mentioned earlier also. So the type descriptor mentions that it's either an int or a string. So basically this value space of x1 consists of the whole set of values of ints and the whole set of values of type string as well. So any type, any value that's belong to a union of those values of the types can be assigned here. So I can say ABC also. So then how do we actually resolve the actual type in the runtime? So can we figure out in the runtime whether it has a int or a string value? Basically it's the value it has, it's belongs to a value space of a specific type. We can do this by using the type test statement. So it basically goes like, you can say if x1 is a specific type, you can give a type descriptor here. So I can just say int, and we create what you call a type guard here. So in here, in this context, x1 is actually an int. So I can actually say x1. So this becomes an int in this scope. So can you guess what will happen? What's the type of x1 in this scope, in the else? So it's basically the type other than the int here. So it is actually a string. So if I just do a string, yeah, this should be assignable. Yeah, because x1, it is not an int. So then the only thing that is possible is it's a string. So if we had another one called boolean also here, then this no longer works. So then it becomes a string or boolean. So then we have to say string or boolean here, and then make it work. Or else I have to again say if x1 is string, then I can do that here. So likewise, so that's how the union type system works in Ballerina. So we also have a special type called a nil type. So it's basically a nothing type. So that means there's no value there. So if you just say it ought to be some value assigned to that, there can't be a nil value there. So we explicitly have to say if there's a chance of being nil, we have to mention that in the type that it is possible. And actually the type and the value is also nil as well. We use the same symbol for that. So then we can actually assign nil to this value. So we can also check the type of it. We can say if x1 is nil, do something, and so on. So this nil type is useful in scenarios like here, when we say in the mapping type the student record, if the college value is there or not. So we had to say if it's not there, it will return a nil. So it will return either string or a nil value. So basically this can be mentioned in a shorthand manner by using this string question mark is basically equivalent to saying string or nil. So it's the same thing if we say it here and just say this, it will have the same effect. So it's just a shorthand version if I just say string question mark. So then we can say, okay, correlate is string if the is the value available in the variable, and if it's there, we can print it like that. So in that case we didn't have that, so if we put it, yeah, so we can see that the type check said we can do that. So I hope everyone's following this well without a problem. Again, if you have any questions, please send us a question in Slido. Now moving on. So now we check the mapping types. We can move on to object support we have. Sorry. So objects are basically, again, something, a structure that has behavior also. So if we create something, we can say, okay, you can say it has you can have an init function in an object. It's basically similar to a constructor in other languages. So here you can initialize the fields we have. So using self, basically we refer to the object instance itself. So similar to like this in other languages like C++, Java. Can also have methods here. Can say, okay, put a edge. Okay. Let's say we get the current time, we get the current year from it. Get it here. And using that, we can calculate the rough age of the person. Likewise, let's do a quick check. Let's create a person. So objects are initialized using the new operator. So you can give names. Likewise. Just not to get confused, just rename it. So you can see here. So that's basically how you create objects in Ballerina. So these are similar to like classes we find in other languages. So you can define behavior here by encapsulating other data items. So let's move on to basically functions. Functions, we have the behavior we have in Ballerina. So you have already seen basically functions in use. We define some functions to be used now. So similar to, so like very familiar to other languages when you use functions. So there are some unique aspects here. So where like things like REST parameters, defaultable parameters, and so on, which are again they're available in some of other well-known languages as well. But I'll anyway explain what are the features we have here. So starting off, so if we just have parameters like these, these don't change. These are like constant operations. Basically, as in these are required parameters when we have a function. You can say add so we have to give the return type here. So these are required parameters. So we basically use it like this. So also we can have defaultable parameters. Those are basically optional parameters with default values. So let me show you an example. Let's say I do multiply operation, then I want to probably log this operation as well, maybe. So by default I don't want to log it, but if someone wants, they can enable logging and have it like that. So I can just put a message saying if logging is enabled, just say and so on. So by default it won't log it, but we can also say true, and that should basically give the log value. Let me check that again. Oh, I ran the wrong one. Functions are well. Yeah. So then we also have, as I mentioned earlier, REST parameters. So here REST parameters are basically varargs, as you will find in other languages like C and so on. So if you have multiple parameter values that you do not know how many there will be, so you can have this syntax as well. So let's say we can have something like this. can simply say okay, all, and give any number of elements as we want. So when you have a rest parameter, it always should be the last parameter in the parameter list of function. So so here we just have one here, but when you have multiple required parameters and so on, those should come in the beginning, and they should be there in the end. Then let's check out function pointer support we have. So function pointers are useful, especially when you want to create systems like when you do not know the actual logic you want to execute until at that point at the runtime and so on. You want to dynamically switch it. Then function pointers are useful, where someone can provide you the actual pointer with certain signature and you can just execute it. So let's see, for example, so this calculation operations, how we can use that with function pointers. So let's say we create a function called get operation, where you get a operation name and it will return a function pointer. So function pointer, the type is basically just the function signature you give. So you give the function, the parameters, and the return type. So you say we will return a function which takes into integers as parameters and returns an integer. So we say if the operation is add, let's return add. Operation is, let's say, mod. So let's create an inline anonymous function and return it as a function pointer. So we can do that also. So we can say yeah, else we'll just return a no op function which actually doesn't do anything. It will always return 0. So there's a single line function definition also we can do, like in this format. So here we can say, so this is a shorthand version. So it says x and y are the parameters, the int parameters, and we can actually use them. You can just say, can do things like this and so on. You can actually use these parameters, and you can basically put a single expression there as the body. So this would be the return, the value that is returned from the function. So they will actually execute that expression and return. So you're only allowed to have a single expression there, or else if you have multiple statements or expressions, you have to use the full body. So now we have this get operation. So let's see how we can use this. So we can create a pointer, function pointer type, and say, okay, give me a function. And we can directly use it. So likewise, so in this case it should just add the two values, since that's the function pointer we are supposed to get. Let's see whether that happens. Yeah, so in that way we got the operation like that. So in the same way, if we just change the operation, it should do a modulus operation and return the value, just 10. So that's it for function pointers. So, and also there's also closure support in Ballerina. So let me show you how that is done. So closure is basically we return an anonymous function where that function has access to the enclosing scope as well as the environment. So you can set some values, and it will have that context even after the enclosing function has finished execution. So I'll show you a quick example. So let's create an adder function where returns a function with the single parameter, which returns an int. So this will return a function so it will return a function that calculates the outer scope and closing scopes x plus the variable value y that is passed in when it's invoked. So we can do something like so now this adder5 function we got basically adds 5 to any value we pass to it. So because the closure it already contains this x value with 5, and when we give 20 to it, it should return 25. Yeah, likewise. So I hope that part is clear. Again, if you have any doubts or additional questions, do please send a message so we can check it. So now we basically covered basic types, the mapping types, functions, objects, objects also. Now let's move on to the error handling constructs. So there are specific error handling features in the Ballerina language. So let's get a simple example where we read in a user's input and parses string as an int. So we want to read an int value from the user. How do we do that? So this is done by first reading the input value. So in the IO package, there's something called readline. So we can prompt saying enter value. So that string value would be read in. And now we have to convert this input, the string, to an int. So this transformation may not always work, obviously, because if the user puts in some other values other than an int value, it should fail. So how do we handle this? So here we have, so let's first import the int package we have. So from string, okay, so it says incompatible type expected int found int or error. So before that, I'll explain quickly what this int, so the single quote int is. So here we call these quoted identifiers. So the reason is int is a reserved keyword in the language. So when we want to use keywords such as that, we have a special notation where we put a single quote and the reserved keyword. So then it will be specially marked and exempted from that. So the internal system knows it's an int, but in the code it's written as the single quote and the identifier. So for us to make it easier to use this identifier, we can actually assign it another alias for that by saying import this specific module as the alias value. So we just ints. So after that, using this ints symbol, we can refer to the same module. So here we say we have a function in the model called from string, and it takes in an input string and returns an union type of int or error. So it's not an int only, so it should be an error also. So error is an inbuilt type in Ballerina, so which will have any contextual information, the error cause, the stack trace, and so on. So when we get a result like this, we have to always do a type test and figure out whether it is the correct value, if it works without a problem, and we can use it. Or we can say error. So we can print the error information as well. So if you put an integer, it works. Put something else, it will fail with a number pass error. So that's the basic pattern we use in the error handling. So in this way, we can also create our custom errors as well. So this is done by defining the error types. An error consists of the error reason and the detail and the stack trace. So the error type is uniquely identified by this reason and the detail. So we have the reason, we can use get it from the reason method that's available there, and also the detail as well. So if we are creating our own error type, we had to give this reason and the detail structures in creating an error. So the reason is basically of string or subset of string or subtype of string. Detail is also a structure that's there internally, which should have so I'll give a example type. Yeah, let's call it file error detail. So the error detail should have the message, optionally at least, error cause, and any other fields that we want. So this makes sure we need to have these, or it will not be of the type that's required by the error. So then we have to define the error reason. We can define a constant. So here it's shorthand way of constant file error. So this is a constant string actually. So now we can basically mention a error type descriptor using this format. So here we can actually define like this. So now this file error becomes an error type by which is explained, which is defined, is shown by this type descriptor. So this is a type descriptor. So you don't really need to define a new type like this. You can actually directly use type descriptor as well. So basically I can create a new error by saying this, or I can just say this as well. So it will be identical. So so now you defined a variable of this type. How do you create an error value actually? So for that we create we use this error constructors. So this is the error, this it's like an error function. So here you can pass in the error reason. So you can say file error, and optionally you can also give the field values for the detail structure as well. So this is given by not creating an instance of this, but providing the additional fields that are there as name parameters. So here you have to give like path equals and so on. So then internally details, yeah, we have to close this. Yeah. Oh, yeah, this is optional also. Yeah. So now creating it, gave this, so it's assignable to the file error. So likewise, so basically now we can at other places where we get this error, we can type check it and see whether what kind of an error we got. So we can say if like is of file error by giving this file error type, or we can directly give the okay. So if we just have a type like that, so we don't know the exact type. So in the runtime we can see if it's of this type by giving this, or we can directly give the type descriptor also, which would be exactly the same behavior. So if you do this, this should ideal print. And because of the subtyping rules of error, so the error type is identified by using these two, the reason and the detail. So if we just have file error, so this is still a subtype of this type, so this should match also. Likewise, so that's basically roughly how error handling works in Ballerina. So in this way you can create like other error type hierarchies and so on by using union types and so on. So you can, if you have multiple error types, you can create a union of that and create a new type which will basically represent all those errors, and likewise you can create a hierarchy in that way by basically creating unions on top of each other. So that's basically for error handling. If you guys have any questions, can take them. Okay. Seems everyone's good. Now the next section is, so we cover the error handling part also. Now we can go into the concurrency part of the language basics. Let me create a new file for that. So the concurrency model in Ballerina is again a bit unique. So we have a lightweight, sort of like a lightweight thread architecture called strands. So here a strand is a unit of execution internally, where multiple strands can be assigned to a single physical operating system thread. So you can have multiple strands doing an IO operation, one doing some CPU bound operation, and so on. But one of these will be actually taking up, will be executing on a physical thread. So we have, so in a strand, the idea is if one is doing an IO operation, for example, it doesn't have to block an actual thread and use those resources where in the same time someone else could have used that thread. So we don't, rather than creating a lot of threads like that, we can have a minimum number of threads and efficiently use the resources that we have in the machine. So especially when we have non-blocking IO, so this is very beneficial. So as we will see in the networking part, I'll explain how the non-blocking aspects are implemented in Ballerina. So this makes it very efficient in implement the network operations and the functional around that, and also it gives a much better user experience. So so the concurrence constructs, I'll start with these workers that we have. So worker is the actual construct we have in the language where a single strand is executed on. So if we create a main method or anything like that, we can have multiple workers inside the method. So these are the concurrence constructs. These are concurrent constructs that can execute independently. So when we execute the main function, so these will be separate. So only way of communicating between the two would be using message passing. So I can just say, okay, like this, and I can receive a message that I'm getting from W1, W2. So from W1, so I probably do some operations, do something, and send some result to W2, and he would also will do something, and after that he want to receive the value that is sent by W1. So here we have this the message send receive actions using this arrow notation, where you can retrieve those and put to a variable. So something to note is the compiler tracks these operations and make sure we will not have for example, a deadlock scenario because of these message passing actions, because they don't match up properly in the flow. For example, if I remove this gives an error saying it doesn't have a corresponding receive action in the other side. So when you only do this only, you will be able to compile. So if we do a quick on this quickly, so you can see the message passing action. So I'll just quickly show the sample that's there in GitHub that I have done. So here I have a worker scenario which again do some operations, do some message passing, and at the end wait for all the workers to execute their operations and get the results from the processing they did. So you can see here, so if I execute the work operations here, you can see here those are the results that we got from the interactions here. So those are the worker functionality we have. So, and also similarly the other concurrency construct that comes in use that comes generally is futures. So in functions we can execute them asynchronously and get a handle for a future type variable, which we can query the status of its execution later. We can ask whether it's done, or we can wait for it and get the result after it finished executing. So here what I'm going to do is I'm going to just start this function that calculates this Fibonacci number, and in the meantime, while that's happening in the background asynchronously, I'm doing a web operation like to the network and getting that value. And after I got that value, I'm going to wait for the Fibonacci execution to finish. Then I'm going to just print both of them. So just make sure, then we make sure that the I operation also happens without waiting for the CPU bound operation to finish. So let's see how that works. Yeah, so you can see here we just did a request to this example.com, we get a response, and at the end we just print both of them, the Fibonacci value and the other one. So basically it gives a rough overview how the concurrency constructs work in Ballerina. So like these simple things we can very conveniently do in the language without worrying about this specific too much. So now let's move on to so we covered most of the main things. Let's quickly check the taint analysis support we have. Taint is basically I'll quickly show the code we have. The idea is so we in Ballerina we try to be inherently secure as much as possible, where any data that is not trusted we try to minimize the usage of that. For example, any data that comes to the network or user input and so on. What we do is the compiler explicitly mark them as tainted. So so in the in somewhere in a code that we explicitly signals that we wanted untainted data or data that is not dirty, sort of. In those contexts, the compiler will catch those scenarios and give a compiler error. So it does it basically does static analysis and figures out whether we can use these values or any derived values of those tainted data at these secure locations. An example of that would be our database connectors, where for our SQL connector, for the SQL string, it cannot be a tainted value. So anything that's outside or from the user must be explicitly checked and cleaned and marked as untainted and used in that context. So in that case, in those scenarios, we make sure that we sanitize the input and that it will not have like things like SQL injection attacks and so on. So basically it notifies the developer explicitly that you have to be careful about those scenarios and reminds that you have to fix those things. So if you look at a quick example here, so here I have a function from MySQL function here, which takes in an string value, but it's annotated saying it should be untainted. Only untainted values can be passed into this function that is probably have some security sensitive operations or something like that. So any other things cannot be passed in, especially data that is marked as tainted. So one of these occasions is the program parameters that you get to the main. So those are passed in by users in the runtime, so we can't trust that. So then when we pass that into this function, we say tainted value passed to untainted parameter. So then the user should explicitly check the data and then mark it as okay, this is safe to go. So that's what we do by this explicit cast saying okay, this is an untainted value. So the developer is knowingly signaling to the compiler that this is okay. So ideally we need to do some checks for the value here, like execute a regular expression against this value or something like that, and only after that we should do this. But here, just for the demonstration, we are directly casting it to this value. So in the same way, so basically these are from the compiler internally, these are marked as tainted. So any data we generate also, we can mark them as tainted. So as I will show here, so we have a variable here s1. So that can be directly passed into the function because it is not tainted. So it can be considered as an untainted. But we can also mark ourselves as tainted. So if we know some scenario internally that this data can't be trusted, we can explicitly mark it as tainted and assign it to a variable. So now this s2 is a tainted value. Since s2 is tainted, anything derived from that is also tainted. So then this s2x is also tainted. So now if we call our functions with that, we cannot call that because it's a tainted value. So then we have to explicitly cast it to an untainted value and use it in that way. Like this. Yeah, we have to give some data. Yeah. So. Okay. So now we checked how taint analysis work. So from the basics, so it's only, so we are remaining the query support and the Java interop support. So the queries, I'll quickly go through that. So queries is a new feature, well, an updated feature we have in Ballerina with the 1.2 release. So it's similar to the language integrate query we see in, for example, in C# and so on, link features. So here we can do execute queries against collections, collection types like arrays and so on. So here we can give, for example, here we have an array of records, person records, and we can execute a query against that, checking for certain conditions, and we can augment it and create new structures out of that. So here we can see the general structure for this is, we say from some source, and where we can give filtering rules, and also after that we can define variables using this let statements. So basically let keyword, where in the same line you can declare a variable and use it. So this is what this let is for. So you can say let int something, another comma, you can give a comma, can separate by commas and have more variable declarations as well. So these variables can be used in the following processing. So for example, in this scenario, what I'm doing is I have these person records where each of them have like the name and the age but in a different structure, in a map, we have the grades. So we have to look up the grades from that map, and we have to create these result records, which will have the name, the college that they can go to, and the grade. How we do this is we will do in here a simple filtering, where we say if the grade is more than 75, okay, we will assign Stanford to them and create these result entries. So here in this let statement, we declare the variable and we assign the value by looking up the grade value from the map. So in the map, we know if the actual map entry is not there, it will return a nil value. So what the actual return value of this is in this expression is either an int or int question mark, basically, or it's int or nil. So which is not what we need here. So what we want to do is, if for some unlikely reason, if that entry is not there, we want to return 0. So we can do this using a ternary conditional operator, or else, as we have seen generally in other languages, like we have a Boolean expression and we can give the two values. So in Ballerina, we have a shorthand version for this called the Elvis operator, where if the value is null, the value after the Elvis operator is the value that is returned, or if it's not null, its value itself is returned. This value is returned. So it just shortens the long form ternary operator that we would write. So in this way, so we define this variable, the value, and we use that to define the condition, saying, okay, if it's more than 75, create a new record value with these fields, the name, college, grade, and return that. So you can see here, so we are dynamically creating record values here. So this is a very useful situation where I mentioned earlier also, because of the structural type system, we don't have to explicitly mention this is a result type or anything like that. We just mention the structure of the values we are returning. Since this structure is compatible with result, it is directly assignable here. So it becomes very convenient to program these scenarios because of the structural type system we have. So after that, after we do the filtering, we get these results as a result array, and we can then basically use it. Let's see, by executing this. So you can see here, so Bill only has 55 grade. So because of that, he is filtered out and he is not there in the final result array. So this feature will actually improve in the future as well. So to support unbounded streams and so on, for doing general stream processing with patterns and so on. So this function will extend more with the upcoming releases. Yeah, so let's move into the final topic in this section, in our first part, which is the Java interoperability functionality we have in Ballerina. So since the current runtime is based on top of the JVM, so it becomes very beneficial if we can interact and use the Java libraries that are out there. So anything that has JVM binaries. This is given to Ballerina using the Java interop features. So using this, we can call any Java class, create instances, call static methods, and so on. That can be done using the interop features. So if you go to java interop.bell, that the sample I have created. So for example, the Java util UUID class has a static method called random UUID. The way to call this would be to bind one of the Ballerina functions here, saying using this Java method and giving the class name and the method name. So here, when we actually call the Ballerina method, Ballerina functions, it'll actually call the corresponding Java static method that's mentioned here. So also that's pretty easy because it's a direct static method. So what if you have to actually create an instance of a class and pass in parameters and so on? So that's shown here with this date class. We create a new date instance and call operations on that. So here first we call get time, and then we call set time to set the time for that date object. So the first one only, so it doesn't take any parameters, so it will just call the method inside the date instance. So here this receiver is the actual object instance we will be using, associated with where we call the get time. So here we see we call this new date object to create an instance of the date class, where we get as a handle in Ballerina. This is just an opaque value that we use to represent that, and we then pass that value into the get time, where this handle will be used to invoke the actual method inside that. So we'll be calling get time inside the date instance, and we'll be printing that. So in the same way, the set time, you have to pass in the actual handle and the additional parameters that are passed in. So here it's just an int, Ballerina int, which is a Java, which converts to a Java long, which is exactly what we need, and we can, in that way, we can call its operation as well. So if we quickly execute this, we will see it in action. So you can see here, so first we create this UUID, and we got the current time, and then we actually set the current time to 0 and see what happens. So it is actually set to 0. So in this way we can so we saw how the constructors are called, static method, and so on. So there are many other functions to handle exceptions and so on as well, to make sure we can execute any combination we need in the Java environment. So that is it for the language basics of Ballerina. I hope you also got you are able to follow the samples as well. You can, and you executed them at the same time. Again, if you have any doubts, any other questions, you can send that now. Okay, so there's some request to have a small break. So actually, let's have like a 10-minute break and come. I guess yeah. Let's do a 10-minute break and come back. Yeah. So the time there is so now the time, the Central European time is 11:20. Shall we come at 11:35? So a 15-minute break. So let's continue. Something I had in the first part, actually, the section on the sequence diagrams. Actually, I'll go through that also quickly. So because I can actually demonstrate that in the network abstractions part also, but let me quickly show the sequence diagram part of the language also. So okay, if I go to an example, let's get concurrency. So the Ballerina language is itself is based on a sequence diagram model, a concept where the syntax and its concepts are basically created around this idea of sequence diagrams. So anything any code we write here can be visualized as a sequence diagram. So in VS Code, if we create this show file overview, what it does, it automatically, well, it should automatically generate the diagram. Give me a second. restart my VS Code. Okay. So yeah, when it comes to services, so we can see the diagrams. So I'll actually come to the services part and demonstrate that. So let's straight away go to part 2. So in part 2, what we are going to check is the network awareness part of the language. So that's one of the main things in Ballerina. So in this, the idea is nowadays when we create apps, so everything is connected. So we create applications by integrating with other external services, other functionality, and so on. So it becomes a more of an integration problem when we look at the business logic we write nowadays. So we do a lot of communication with external services, making sure they are secure and reliable, and so on. So these are the problems now we have in this cloud native era. So Ballerina is purpose built to handle these scenarios. So let's see these sections. So if you click on the network awareness section, so it has the samples for the HTTP, gRPC, and WebSocket. And first I'll explain the general network abstractions we have. So for that I'll show a simple HTTP service. So I'll start from scratch actually. So we'll just do like a simple HTTP service. So in the VS Code there are templates that you can use. So we'll create the service name as hello, resource name, just say hi. So here we can see in the Ballerina language we have a service concept built into the language itself. So you don't have to import any other libraries or frameworks to create services, but rather it's there as a first level concept in the language. So the type of the service depends on which type of listener you bind to. So here it's an HTTP listener, so this becomes an HTTP service, and these resources will map to the HTTP resources that we will define, and we can basically augment its behavior as I'll show later, so we have an annotation based mechanism where we can give further information about these resources and the services. So here I have a reference to a caller. So caller is the actual caller that is sending request to this service. So that would be the actor that invokes this service. So we have an access to that. So we can actually send back responses to the caller using this instance. So let's say I'm just going to say hello world respond. So here respond actually returns something. So it returns union of basically error types. So it becomes an error. So we have to handle that. So in Ballerina, so every time a function returns something, you have to assign it to a variable. You cannot ignore that. So that's a safety mechanism. Or actually, so there's a special variable called underscore. You can actually assign to that, but for that also you can't assign errors to that. So you can't effectively never at no time you can ignore errors. So that is built into the design of the language. So you have to handle it somehow. So you have to either say error like that and use that variable. And we actually have a, so let's say this resource function returns an error. So we'd probably do something like this, get an error, and if error, we return the error. But there's a shorthand version to do this operation, which is called the using a check expression. So using a check, what happens is basically the same thing. In this sub expression, if it returns an error in the runtime, we immediately return that error from that function. So we return it directly. So we don't have to actually write that logic. So that's just a convenience method that we have in handling these errors when you use the pattern of basically extracting that error and returning it from the function can be done in a single go using this check expression. So we can just say check this expression sub expression, and if it results in an error, it will return an error from this function. So we can shorten the thing like this, and let's run this and see. So you can see it listens to port 8080. Can now do increasing the font in this. So let's just do a curl. The resource paths are by default the service name, and the resource path is the actual resource function name. So it should be hello. You can see here, get the response back. So that's a simple function, a service. We can, as I mentioned, we can change some attributes of the service and the resource by using annotations. For example, we can change the base path to just this. We can say we can do some data binding. We can say, okay, I'm sending request parameter for name. Okay, so name is actually tainted, so we have to yeah, it will be tainted also. Now it will say it's tainted, so we have to untaint it. Okay, now sorry, actually this needs to come here to the resource. We can say path. Here we can say just hello. Likewise. Now let's see how this works. So earlier one should, okay, so I actually became the data bound operation. Yeah, so okay, yeah, so it's earlier one actually mapped to the new variable here. So likewise, you can change the behavior of the resources, the service, and the resources using these annotations. So you can configure the security parameters, transport other transport properties, and so on using these. So all attributes you can take it like that and check actually. So in the next one, let's try to write a service which calls an external HTTP endpoint, how that is done. So the information for this is mentioned here. So if you go to part 2 HTTP, if you go to the readme, okay, it says this endpoint. So this is a GeoIP endpoint where we will be sending requests to it with a host or an IP, which will do a GeoIP lookup and give the location where that that service located, the physical location. So if we actually go to this website, it gives the API, how that is used. So what we will be using is this endpoint, geoip.app/json. So let's see how to write a client for that. Okay, so let's name this geoservice.bell. Let's create a simple service.
IP. Call the okay, so it's anyway the same. Let's keep it like that. So here now we have to do is we have to create an HTTP client. So this should be an HTTP client object. So here we give the base part to the service, basically the host, and then here we can execute it up. It's remote methods. So I'll explain what a remote method is. So here also I'll use the check due to the convenience. So I'll directly return that. So what I'll be returning from the client is an HTTP response. So we call this this get is a remote method invocation. It's specially shown using this arrow notation. So it's not a normal method invocation where we do a dot for that, but it's a special remote method invocation to signal to the system that we are actually doing a remote call. So this is special in Ballerina because with this information we can do other optimizations and other operations like observability, other network optimizations and so on, because we have this knowledge, and it's and it shows that we are actually doing this to the user more clearly. So after we call the get operation, we get the response, and let's try to extract the payload from it. So as a get JSON payload operation, and that also it can have an error because if they are actually not returning an JSON, we have to handle that, and this actually can be tainted. So we have to say it's tainted. Now we have the JSON payload. If there's no error, it will go to this line. Now we can send it back to the caller. Again, we do a check to see if something goes wrong with this. Again, this is value, so we have to explicitly untaint. Excuse me. Okay, now we are sending it back. So our service is ready. Just let's run it and see how it goes. So earlier service is still running. Okay, so that service is running. So let's call this service. So it's hosted in 8080. It's just geo IP now. Yeah, IP. Okay, that's it. So let's see what happens. Okay, so we can see here it says that I'm okay. Make it a bit large. It says that I'm living in San Jose, California, which is correct by checking my source IP from the request. So yeah, so that's how to
write a simple service, and let's see the sequence diagram from this. Oops. Let me check. Yeah, so this is basically the sequence diagram of that service. So you can see here the code we wrote, the service can be visualized in this way. So we can clearly see the actors and the interactions that happen, the message passing and the remote endpoints and so on, are all shown as participants in the sequence diagram, and its execution in the lifeline. So with that we can nicely see like a high level overview of okay, what are the operations, who are the participants, what are the actions that are happening throughout. So we can see here the external actor doing the initial call, and we are getting a message back with the response after talking to the external endpoint. So likewise, so when you have, especially when you have a complicated scenario, it's much easier to look at a diagram like this and see who are the participants and see what are the operations that are happening between those. Hope it's clear until now. Again, if you have any questions, please don't hesitate to send us a message. So let's do a minor change for our earlier service. So we can pass in a IP to it on host. And we can use that. So we can give anything and see where it is located. For example, okay, now this should fail. Yeah, let's say google.com, one of their servers are in somewhere. Oh. Let me see. Oh, this is the base part. Yeah, put a resource config and path here. Oh, so we just gave it. Okay, so likewise we can give an IP or a domain host name, Yeah, so one of the google.com IPs got resolved to somewhere in Germany, and so on. Okay, so some analysis on the operations that happen in this service. So I mentioned earlier that our I/O model is based on a non-blocking I/O framework. So what happens is when we do network operations like this HTTP gets or post or anything like that, we internally use non-blocking I/O to make it happen. In Ballerina, you don't have to explicitly handle this yourself, but we automatically does it basically under the covers. So what happens is when we do things like an HTTP get here, the executing thread or the strand that is executing it goes into basically it does the I/O operation, and the physical thread is released. So that's automatically done by the user space scheduler we have running. So we don't have to actually handle that. In other languages, we have to either do callback based operations or something like that to come back into the execution after that is done. But here we have the convenience of doing the normal programming style. Like it looks like a blocking call, but it's not. Like internally it does the correct thing, so we don't have to worry about that. So it gives you the best resource utilization as much as possible, while keeping the productive, while retaining the productiveness of the developer. So likewise, so our concurrency model and the non-blocking I/O works hand in hand in making these as optimal as possible. So the other factor is when we have like networked services, like for example in microservice architectures, the main problem that we have when moving away from monoliths to microservice, that there are a lot of inherent problems when we have distributed services. So the network is not reliable, message delivery is not guaranteed, and so on. So we have to handle these things as to the best of our ability. So so we have to expect failure, and we have to basically cater those scenarios when those happen. So that's when we call the communication resiliency. So if something goes wrong, we have to make sure, okay, we have to fix that somehow. We have to do things like we should either retry operations, compensate on that, or something like that. We have to make sure those things don't go unnoticed, but should be handled somehow. So that's why we have also put these resiliency properties directly into the clients and the listeners we have. So for example, in the HTTP clients, let's say these endpoints are not reliable, the remote endpoints. If they're not reliable, if they fail often, doing those remote calls to the failing endpoint is time consuming for this service, and it can be problematic. So we have to fail fast in those kind of scenarios and retry later without increasing the load again more and more into the backend. So that's when the that's when patterns like circuit breaker and so on are useful. So using that, what we do is we check the health of the target endpoint, and we see how the service requests are failing or succeeding. And according to certain patterns, according to certain rules, we can say, okay, if it fails for this much of time, this much of requests for this given period, stop sending requests to that. And only after sometimes we'll check whether it's working properly, and we'll come back to the normal mode of operation. So this circuit breaker pattern does this operation. So let me show you a configuration for that. So this is the circuit breaker configuration added to our client endpoint. Here we say we give a, so how it happens is it looks at the request in a rolling window. It checks the last specific number of requests for a specific number of specific time. And so here, for example, we check for 10 seconds and we sample requests we put requests into buckets for every 2 seconds. And in that time window, if the failure threshold goes above 0.2, that means if the request fail more than 20% in the last 10 seconds, we say the circuit is open. That means the requests do not go, the circuit is not closed, the requests do not go into the backend service. So it goes to the open state, and it fails immediately and returns an error code. And after the reset time, after 10 seconds here, we check the backend again, we test it, and if it succeeds, we go to half open state. That means we send some message and see whether it works properly. And if it does, we close the circuit and goes back to the normal way of sending requests back directly to the backend. So likewise, this is what that pattern, circuit breaker pattern, which is useful in that kind of unreliable service in the backend. So in the same way, so we have other options like service timeouts, retries, where you can see a retry configuration where we give a backoff factor where we don't keep on doing retries in the same frequency, but rather we wait with time period in an exponentially growing manner until it hit a certain maximum wait time, where here the maximum wait time is 20 seconds, and then we retry it. So likewise, so again we also have other endpoints like load balance clients, where you can give multiple endpoints or load balance between multiple backend services, and also failover clients, where if one fails, it will fail over to the other endpoint in the list, and so on. So these scenarios are supported in the clients that are available in Ballerina. So now in the next section, so we'll check our status. So we'll talk about the basic abstractions, the resource methods, the remote methods, how the non-blocking IO works, resiliency. Now let's check protocol specific support we have. So we looked at the HTTP services. Let's quickly go through some of the other built-in support we have for like gRPC and WebSockets. So we'll start with the gRPC service. So we have created, so there's a sample there in the repository. So what's there is a small calculator service, which basically, well, it's actually not, well, it's a service actually. It's a service that creates a hash code given a string value. So we have to rename this service. Let's call it the hash service. And yeah, let's try to generate the code for that. So here gRPC basically works on top of HTTP2 and protobuf. Protobuf has the data format being used. So it's a binary protocol, and this protofiles basically defines the interface that we use to define services and to create client stubs and so on. So what we'll do here is we'll define a protofile. So let's call this, call it to the hash service.proto. And from here, let's create the stubs using this protofile. Okay. Now using the protofile, we created the Ballerina stub, so it's created in the stubs directory. Now the next section would be, let's create a new project, Ballerina project to host the actual gRPC service. Let's copy the stub to service. And the calculator service itself. Sorry, I mean the very name to hash service. Let's delete the auto-generated files here. Now let's build the service. So we build the service portion of the gRPC service. Now in this next section, so in the service, if you see here, it's a very simple service. So we still use the service concept in Ballerina. So we bind to a gRPC listener, and we have a resource called hash, and this is the resource that will get invoked later on when we do calls from the client. So here we basically get the payload, string payload, create an MD5 hash, and create a hex value from that, and return it back to the caller. So this is a blocking call that we are doing, a single blocking call, and after that we mark it as complete. So now let's check the client part of it. So here we'll create hash client, clear the auto-generated files. Now let's create our client and client file. Okay, we have to copy the stub here. So in the client, we again, it's a simple operation we do. We create the already generated client, the client stub. We give the endpoint information. We create a gRPC headers structure, and we basically call the operation in the stub, so the remote method, and we get the result and the result headers, where we'll be able to see the result response here. So now since we have all the code, let's build it and run it and see. So first of all, we can first actually run the server part. Okay, service running. Now let's run the client. Gotta build it first. Okay, we built it also. Okay, the client is there. So in the client, we check the command line parameters. So let's just put some data there. Oops. Okay, there's a mismatch in the operation. Hash. No, we copied the file to the wrong place. It should go to the service directory. Okay, let's check it again. Okay, so you can see here we get the MD5 hash to the data we sent. It's done using the gRPC backend. So let's just build, build. So that's how to create a simple gRPC client service and a client. Sorry. If there are any questions on this part, please let me know. So the next part is Websockets demonstration. So let's check that out also quickly. So WebSockets work by upgrading the current and existing HTTP connection to the WebSocket protocol, because in the web pages, so it's mainly from front end HTML pages to the backend HTTP servers that they have initial access to. So they have to first do an HTTP call and then do an upgrade and then change the protocol that they use later. So this is done by using the HTTP 1.1 upgrade feature. So in the same way, in the Ballerina services, the HTTP service has a way to do the WebSocket upgrade. So we just have to put this WebSocket upgrade configuration to the initial the upgrade path service. So so we can see here we give the upgrade path context. So this is the endpoint that the WebSocket client should talk to, and so then it goes to this resource function. After this resource function is executed, the protocol handling passes on to a different service. So this is the upgrade service where we have a service called chat app. This is the actual service which will do the WebSocket communication. So here what we are implementing is a simple chat broadcast application where in the Ballerina side we have a single service. Anyone who connect to that service from web pages, any message sent would be broadcasted to all the other participants in the system. So that's a scenario. So after the upgrade is done, by using this, we get a WebSocket caller instance which represents the WebSocket client in the other side. So here we are just we are setting some properties to track the track a unique user, basically a unique client, and we store that as an attribute there. So we just generate an UUID and set it to uniquely identify that WebSocket client. After this upgrade is done, it moves the execution to this WebSocket service, where it has events like on open, on text, on close, and so on. On text is where when the WebSocket client sends us some text payloads our way. So what we simply do is we get that payload. We also look up that attribute which has the user value and create a message and broadcast it back to all the other participants. So they should be able to retrieve that message to those basically web pages. So that's basically it. So we can see here how simply we have like naturally model the operations of the WebSocket protocol to the service concept we have, service and the resource concept. Yeah, it matches nicely with the architecture we have for services, and it gives the ultimate flexibility and the functionality when it comes to implementing the operations we need. So so this is it. So it's just a 55-line code for the whole implementation, and it's very clear. It doesn't have any confusing APIs and so on. It's very clear what's happening. Let's run this and see how to do this from web page. So now the service is up. Now we can just go to a web page and like create some WebSocket clients. You can see here the user connected. We got the message when we connected to our WebSocket server. Now let's send a message. So at the moment I just got it looped back to myself because there aren't any other pages. Let's check it again. Let's do the same thing for the other page. Connected, and so you see the other participant also saw that I came, and now I can send a message and says the other one got it. Likewise. So we see how the communication is done and how easily we got it to work using Ballerina. So let's check our progress now to see where we are now. So we have finished the network part also, network awareness. So we are done with that part. Now let's move on to the next section also. If there aren't any specific questions in this part. So observability in Ballerina. So we follow a inbuilt observability concept where anything that can be observed by default without much developer intervention, we do that in the interest of having like sensible defaults, so the developer doesn't have to go and do every single thing, but most of the common things can be done observability wise. So we gather a lot of metrics and tracing information from the client connectors and the services and so on that we have. Since we have specific contextual knowledge about the operations we do, we can basically give more meaning to this functionality. So let's see. So let's take a service we already implemented, and let's enable observability for that. So so it's a global property that we have in an application to enable observability. Then it applies to all the client services we have, and let's see how we can monitor our application like that. So we'll take the geo service HTTP service we implemented, and let's see how we can observe it directly without basically changing any of the code that we already have there. So for that, let's go to the README of our guide. So what I'm going to do is I will be running Prometheus to gather the metrics. So that's what we use in Ballerina, Prometheus. And then we have a Grafana dashboard which visualizes, which basically has a dashboard visualizes the metrics that's collected by Prometheus. And also for tracing, we follow the OpenTracing standard. So here we will be using Jaeger in visualizing the tracing information that we collect also. So so to run all of these, I'll be using Docker. So using Docker, it's very easy to run this rather than installing everything in your machine. We can directly run the Docker command and it will run its own container. So so the first one is for running Prometheus. So I have a Prometheus.yaml file here where you have to put some configurations into it. So the first thing is you have to give the targets. So we have to pull the stats from the metrics. So the Ballerina service exposes an endpoint in that where the Prometheus service should contact it and get the stats. So let me show what happens when we run the service with observability enabled. So these are our earlier geo service. Okay, and this is, oh. So we see here now some additional endpoints are starting up. So along with the HTTP listener, HTTP service we have. So we have a Prometheus HTTP listener and a Jaeger. And Jaeger has also started, the Jaeger client has started to publish data, and so yeah, so those are the main things. And so this is actually the service endpoint. This is the Prometheus related endpoints. This port logs to the shows the same single endpoint. So basically this is the endpoint that Prometheus will be contacting. So in order to connect to this endpoint, since we are running Prometheus in Docker, so we have to give an external IP for that. So make sure you give your external IP to the configuration that's there in Prometheus.yaml. So which is here. So I have given that. So you have to also do the same thing, because Docker has to go out and come into the service that we have outside of Docker. So now it's just a matter of running running the Prometheus server. So here using Docker, I just started it. So now let's start Grafana also. Grafana server. Next, let's do the Jaeger server for the distributed tracing. So now we have all the three applications needed for the observability features. Now let's invoke the service also to make sure that it generates some stats. Likewise, then fail requests. Okay, so now the next would be to configure Grafana. So let's start up Grafana. So we'll start by adding a data source. So here we have to give the IP where so again here we have to give the external IP. And 9090, it's both are mapped anyway. So after the data source is added, let's add the dashboard. Let's import it. The dashboard ID is this. Okay, so it looked up the dashboard. We select the data source, then we import it. So here we can see the stats are visualized for our HTTP service. You see we have done 11 requests, so actually requests per minute. In the past minute we have done 11. So if we do some more, it should increase. So there's a 5-second sampling rate. So yeah, here the stats got increased. So likewise, there are a lot of stats available here, which we can drill down and see what's happening. Now let's go to the distributed tracing aspect. So in the same manner, so we go to the Jaeger dashboard. So we select the service, GeoService. Let's find all the traces that are there, and you can see here there are 19 traces because there were 19 requests earlier, as we saw here. So and the traces. So all the requests are here. We can drill down to the request and see all the spans to see each aspect, how much time it took to execute each step in the execution and so on. So it goes from the outermost service resource to the HTTP client and so on. And also the things like the respond operation and so on. So yeah. So yep. So that's it for the observability part. So now we saw like how we can easily enable observability in a Ballerina application and get these useful stats exposed by default. Of course, if you want to augment these results, you want to add some more details and so on, there's user level API also that you can use for the observability. But as you saw, like most of the useful stats and trace information are already published by the system automatically. Are there any questions, concerns for the section so far? Okay, then let's go into the final stage also. Here we are going to look at some deployment options. So starting from Kubernetes Docker deployment. So how we create Docker images and how to deploy into Kubernetes using Ballerina, and also how to create Lambda functions using Ballerina as well. And at the end, we'll show you some examples on how to use GitHub Actions to create a CI/CD pipeline with Ballerina. So starting from Kubernetes, so what we're going to do is, again, we'll take that GeoService implementation we did, and we'll deploy it to a Kubernetes cluster that's out there. So for our use case, will be from my end, I'll be using the Azure AKS service, Azure Kubernetes service. So there I have created a Kubernetes service instance. So here you can see KDS test one, and I'll be using that to deploy my service there. And let's see what it takes from Ballerina to do that. So if anyone is following this section, you can do the same commands, do the same operations, and deploy to a local Kubernetes cluster as well. There won't be a difference there. But I'll be basically demonstrating how to do a real life scenario by deploying it to the cluster in the internet and getting a public IP to my service. So my Kubernetes is kube control is already pointed to the Azure cluster, so you can see here. Okay, I already have a deployment running. Let me remove this first. Well, it doesn't matter, we will override the thing when we deploy it again. So basically we take the same service that we did earlier, and what the only change we have done is we created we added this Kubernetes annotations. So what happens is we can get the service, we can annotate the service construct with Kubernetes annotations to enable Kubernetes functionality, basically to expose our service inside Kubernetes. For example, we had to first add this deployment annotation, and to expose our service as a Kubernetes service, we have to add the Kubernetes service annotation as well. So here we can give things like service type. So here I'll be doing a load balancer service type, and I can also give the port. So I'll expose it in port 80. And the deployment, I have to give some extra properties to configure it. I gave the Docker Hub username password as environment variables, where the Docker image would be uploaded to. So I'm always pushing that. So let's see what happens when we run it. So let's build the application. So in this case we build this first because there are some more artifacts that needs to be built with our code. Here we see some additional operations are executing. When you are compiling the source code, the compiler sees that there are some additional annotations that are there, which triggers some compile extensions, which generates the Docker image and also generates the Kubernetes artifacts as well. So here they just point out the command we have to execute. So we execute this command, and then the Kubernetes artifact is automatically deployed. So it replaced the earlier one. So if you get the service, so this is where the service is at. So let's remove it and start from the beginning just to show how this works exactly. So we are terminating the earlier pods, and let's start it over. So we see the earlier service is gone now, the pods are also not there. So let's deploy the application again. Now we see the new pod is created 6 seconds ago. You can see the services. A new service is created and it's pending the external IP. So when the external IP is available, it will show here. Then we can invoke it and see. So that IP is still pending. Okay, so just now we got the external IP. Now using this IP we should be able to invoke our service. Let's see, the earlier endpoint was this, the local one. Let's talk to the one in the internet and see whether it works. So here it's port 80. Yeah, so now we send the request through Kubernetes in our Azure case to the cluster, and just like that we got our Ballerina application, the service, and deployed in an external Kubernetes cluster very quickly. So since the compile automatically generates the Kubernetes artifacts, we don't have to mess around with the YAML files and so on. We just directly use it as it is, or if we need some custom changes, we can do that also. But the base configurations and everything is automatically generated. So let's move on to the other section now, which is the AWS Lambda deployment. So similar to the Kubernetes deployment, where we get the service and deploy it in Kubernetes, you can easily do that with a Ballerina function as well. We can get a Ballerina function and deploy it in AWS Lambda. So let me show that with an existing function we have. So this is a simple function which creates an UUID by calling our system UUID function. So we just have to create a Ballerina function, annotate it to this AWS Lambda function annotation, have this specific function signature, and that's it. So let's build this and see. So Ballerina build functions dot bal. So when we do here, when we do the build, we can see here we get some extra additional instructions. So again, similar to the Kubernetes one, it generates an AWS Ballerina Lambda function zip file, so which has the Lambda function implementation. This is what we have to deploy, and it lists down all the functions that are there. So we only have UUID, and we basically have to execute these commands to deploy this in AWS Lambda. So actually these two commands can be merged into a single command as well. So I already have this. So you just basically have to fill in the placeholders with the function name and the Lambda role ARN that's in your account. So this is the command. So for that, let me remove the function that's already there. Okay, now let's deploy the new one. Okay, the function is created now. Now we can just invoke the function. So of course, when the AWS Lambda function is there, you can use it in multiple places. You can directly use it through a API gateway or through as syncs for other events in AWS and so on. So I'm directly invoking it to the AWS command line tool here. So you can see here it generates the UUID and prints it here. So that's how you basically do an AWS Lambda deployment using Ballerina. So now basically we are nearing our end on the functionality we have. The final topic is using GitHub Actions in creating CI/CD pipelines. So if you have any questions so far, please let us know. So for GitHub Actions functionality, you can basically, so we support mainly 3 aspects, so which I have listed here. So if you go to the README, GitHub Actions, so we can use it for automating Kubernetes deployments. So whenever you have the source code updated or doing a release, we can deploy it to a remote Kubernetes cluster, your application. Also in the same way, we can do Lambda deployments, and then we can do Ballerina Central deployments. That's for deploying modules, deploying Ballerina modules. So Ballerina Central is like a module repository where other people can use, basically share their modules and use them. So if you go to central.ballerina.io, you can find these modules, you can search for it and find it. So likewise, so one of the use cases of the Ballerina, so the Ballerina Central deployment is using GitHub Actions to define workflows to automate this release cycle and deploy it to Ballerina Central. So we actually already do this for our modules that we maintain by WSO2, and so basically in that way, when we update the code and we do a release in GitHub, it's automatically built, tests are run, and it's automatically deployed to Ballerina Central as well. So let me show you an example of that happening in the Ballerina Central deployment. So there's a module called Azure CV module. It's for computer vision. So this is automated by defining a workflow. So if you look at the workflow for this, so what happens is, let's look at the release YAML. So every time we do a release, it'll do a push or a deployment to the Ballerina Central. So each change, each pull request commit will just build it and run the test, but each release will actually do a push to the Ballerina Central, which is what is mentioned here. So here in GitHub Actions, you can provide things like API keys, the Ballerina Central access tokens, and so on as secrets, so which we can use it in the workflows. So here, let me try to do a new release of the Azure connector with the new Ballerina version. Let's see if that will work. I'll quickly update the version. So the Ballerina GitHub action is hosted in the GitHub workplace. You can go to Ballerina GitHub action, marketplace, and see details on that. So the 1.2.0 is there. The usage sample is there, where you can use it in your own workflows also. So I incremented the like a patch version. Let me commit this and let's see what happens. So when you do that, a workflow is kicked off, it's executing, and ideally it should build, run the tests, and give the result what happened on the execution. So all of this happened just by a commit ID to the repo. So the Ballerina action makes sure the Ballerina code is built, the tests are run, and gives the result on that. So yeah, you can see here everything is green, everything passed, the test passed, and everything is working properly. So we can now actually do a release of this and see how the Ballerina Central push happens automatically. Okay, let's publish a release, create a release from this. Okay, release created. Let's see if the workflow is triggered. Yes. Deployment workflow is triggered from that, and the deployment workflow should build it, run the test, and then finally do a Ballerina push to the to Ballerina Central as well. So if you look at central.ballerina.io, the last upload modules are these. Oops. Build. Oh, that version actually already exists, so we updated the wrong version. Yeah, 0.1.2.23 is already there, so probably we would have pushed it manually. Let me update it to 24. And so then let's create a release on that. Okay. So 24. So this. So the release deployment is happening in the workflow. Okay. The push is done successfully. Yeah. So now let's see in Banner Central whether the module got updated. Yeah. So we can see here from by the release we did in GitHub, the GitHub action automatically build the thing using the Ballerina GitHub action and deploy it to Banner Central automatically. So we don't have to manually go and intervene in those operations. So you saw how the workflows are defined. So you can go to these samples and see how the continuous integration, the release workflows are implemented. So here, for example, the release flow is triggered for every release event, and we basically run these steps to build, test, and push it to Banner Central. So in the same way, we do the other deployments as well, Kubernetes and Lambda. We basically encode the Kubernetes, the kubeconfig as a secret there, and the Lambda also the necessary keys are given, and we basically execute the required GitHub actions, and finally along with the Ballerina action to get these deployments done. For example, this is the Lambda action. So there we use the Ballerina action, Ballerina GitHub action, along with the AWS CLI action to do the build the Ballerina AWS Lambda function, and then do the push to AWS Lambda as well. So likewise, similar workflows can be generated like this to create any deployment scenario. So the information is there in the GitHub repo I posted. So all the resources, the links, and the workflows are available. You can try them out, copy them, and test them out in your own applications as well. Oh yes. I see we got some questions, and Lakmal or reply to them already. So yeah, I guess the multi-cloud environment question is clear. So one question is how to easily write an application in a multi-cloud environment. So again, so since we used Kubernetes here, so any place where Kubernetes is supported, you can basically push to any compatible cluster. So all of them use the same protocol. So it'll basically run anywhere. So I demonstrated using a case, but in the same way, GKE EKS, as Lakmal said, it will work in anywhere, and even in your own local Kubernetes cluster also, it will be the same process. yeah, the other question is to selectively deploy to AKS or AWS clusters based on some criteria, but yeah, that's up to the user on how to handle that part. So we create all the artifacts. You can make the decision after that. So are there any other questions? So that's basically it for the topics we had. If you guys have any specific other questions or any other aspects you would like to specifically check on, do tell. We can talk about those things as well. But according to our schedule, we basically covered all of those aspects. So I put some other links there as well in the GitHub repo, like specifically for the Ballerina by example and the API documentation. So if you go to ballerina.io learn pages /learn, you will find a lot of other resources where there are a lot of examples for each of the features we have in Ballerina, and also the API documentation for the standard library. So please check them out. And so also if there are any beginners to programming, so we actually recently published a book for beginner Ballerina programming by myself and Lakmal. So that's mainly for beginners like who are starting off with programming. So it teaches programming using Ballerina. So but it goes into other more advanced Ballerina topics also, but it starts from the beginning. So if anyone's interested, I put a link there also. Okay guys, thank you very much. It has been it was a long session. Thank you for everyone who participated. Yeah, please give it a try if you're interested. Thank you.